Good afternoon, everyone.
Afternoon, sir.
Good afternoon. Let us wait for everyone to. Can someone who is showing five presenters here give the presentation rights? Ajit, Himanshu, Rahul, Rishabh, they're all showing in my screen as a presenters. Yeah, thank you. Yeah, thank Okay. Okay. So before we start today's session, okay, today we will be covering duality, most part of the class, and then we will start depending on how much time available about the transportation and asset. Jump into the today's topic specifically. Just a quick recap, if one of you can possibly give a quick recap of what we have done in the last class and possibly uh, a kind of a little bit more on that what we have done so far now. That is even more important. Anybody just it is not any marks for there, neither any penalty for response. Yes. Who is this? Yes, Ajit, you are absolutely correct. Can someone give a little bit more? When I say brief, I was not expecting so much brief. Yeah, I mean, you are correct, Ajit. I mean, that's absolutely fine. What we are trying to do. So, what we have done as of now, let's have a quick recap. Uh, anyway, first class was mostly global. We said that real life or problem may not be exactly how you solve in your classroom problems. So keep that part anyway aside. We first started with the foundation of how to formulate the LP. And then we said in an LP, because everything is in a linear form, that's why it is LP. Then we started formulating LP. We said that in LP we have an objective function. How we are going to achieve that objective by selecting certain level of activities. The activities which are dependent on some set of resources, and the resources have certain constraints in whichever form. So the objective may be maximization profit, minimization cost, and the resources may be upper limit of the resources or maybe the lower limit of the resources. For instance, in case of demand, we know that there was a upper bound of the demand in some of the problems. Optimal instance were not able to meet the demand. In fact, it was not profitable for the firm to even try to meet the demand. Those kinds of instances. We then, what we did is that we kind of tried to solve a two decision variable problem in a graphical representation and have seen how to interpret the zone of feasible solution and also what are the feasible solutions. So we talked about corner point feasible solutions. We say one of those optimal corner points And then we followed it in the Excel how to solve it using solver, Excel solver. For most of the problems that in classroom, Excel solver is good enough. For a real life problem, depending on your number of variables and number of constants, solver may be not the right tool. However, in maybe 80% of your problems does not deserve any software tool. Anyway, so we try to solve it using solver. About some of the two important aspects, which is known as shadow price, or also sometimes shadow price is called the dual price. So what is it? That we will talk today a little bit more on that. But we have seen that in an Excel solver, when you go for a sensitivity analysis, for each of those resources that I have in my hand has a shadow price associated. We have seen in addition to the shadow price, we receive couple of other prices, which are like the upper bound and the lower bound, means maximum those resources, as well as the coefficient values in those sensitivity analysis. We conclude that the resources which are fully exploited means we have achieved maximum is possible to achieve. Definitely are going to have a shadow price. But there are resources who are not fully exploited. The shadow price is 0 because the resource theoretically are abundant, and therefore that resource unit increase of resource does not add any value to my objective function. We also did the solutions, but it is better to practice some of those things. Just pick any problem in the one or two problem from your textbook. Try to understand, because sometimes problem statement is something ambiguous. Sometimes the problem statement, there are too many junks that you will need to understand what you have to take it for your formulation and what you should be discarding. Do that, practice at your home, preferably something for which solution you have, means maybe solved examples or already given. In your exam, you may get one of those problems, you may get something totally different problem, or you may get a little bit of other problems which requires a little bit more thought process. Okay, so then once shadow price we have done, then in the last class we have covered one of the matrix methods, which is a simplex. It's basically algebraic method, and we have stated that it can possibly be visualized geometrically, exactly the same way we visualized the LP problem in a simplex method, which is an LP problem solution approach. Can be visualized geometric approach to solve linear solutions. In order to solve that geometric approach, we said that first thing we have to do is that convert those inequalities in the constant into equalities. In order to convert those inequalities in equalities, we have introduced couple of dummy variables. What we called them? Dummy variables. Anyone?
So slack or surplus variables.
Perfect. Thank you. Yeah. So we included slack or we included surplus. So basically, slack is source will be left out after I have achieved my optimum, or surplus is how much. And surplus is how much additional activities I might have performed, which is not sellable. In a typical production environment, is basically you produce, but you are unable to sell it. Because you produce, maybe because of several reasons. Why do you produce extra? Because it may be because your production has a batch dependency, that every time you produce, you'll have to produce certain amount of something like that. So we introduced surplus and noted S1, S2 and something like that. And then we said that now it is a set of equations which we will have to solve for x1 and x2. The values of x1 and x2, and that values of x1, x2 is my optimum solution, which maximizes my benefit. And obviously x1, x2 and s1, s2, which are slack variables, has a non-negativity constraints. Okay. And then we are talking about basic variables, non-basic variables in the simplex tableau. At the first iteration, we have only the z coefficients, or rather the z variable, and all the slacks are highest possible slack that is in my system. And then slowly we moved into subsequent iteration, how we chose the particular activity. We chose the activity which contributes maximum to my objective function. And on that variable, we ensure that now we concentrate to that resource which has on which that activity is highly resource based on minimal ratio condition. That means the coefficient of that x2 column to the ratio of the solution column we have seen. Whichever has the minimum ratio, we chose that column as my pivot column. Then we removed one of the, then we did some operation so as to ensure that in this column, all the other values are 0 except this pivot column which has to be 1, and changed all the other cell values so that the actual remain intact. That is done is how we have done it. Any operation we have done on this row has to be done each of those cells in this row, which includes the solution part as well. So like that we have approached, and then on the right hand side we can see slowly after 2 iterations, because there are 2 variables, sorry, 4 variables and 2 constants, we have foreseen 2 kinds of iterations with actually 2 maximum iterations. On the right hand side, we have seen we x1 and x2, which provide me a solution. And we kind of discussed that at my when I've achieved my optimal on my the top row, which is the z value row, I'm most likely is going to have some positive slack, or at least some positive values of S1 and S2. They are not actually positive slack as such, but those are positive values. Then we talked about optimality solutions when we'll say the optimality and feasibility conditions. To cover a couple of other special cases of simplex, but I think we were going a little bit slow. I can speed up, however, for the LP, I think it's better to understand, get the crux of it and all these things. So today we are going to discuss about the duality. Understanding this duality is equally important like understanding the importance of shadow price. And if someone who has internalized the importance of shadow price, whose alternate name is the dual price. Shadow price of a resource is, can somebody tell me what is the shadow price of a resource? The definition or some kind of meaning? Anyone? What is the shadow price?
So it's the benefit of changing 1 unit of a resource.
Perfect. Thank you. Yes. So basically, shadow price is nothing but a unit contribution of a resource to my profit. I'm saying profit because we are dealing with maximization problem, which is both in terms of profit or benefit. It could be minimization of itself. So when it's a maximum contribution to minimization, it's actually the coefficients that you will have to take care. So essentially, a shadow price is the contribution of 1 unit of my resource to my objective function. So duality, before I jump into the more boring statements part of it, let us understand the duality concept. We have solved, and this would just, I would request you to recall what we have done in the class for optimizing Eckert versus EC. Okay, the exact values you may forget, which is fine. So in the Eckert versus EC, what we have is that I have 8 hours of study time and 1250 calories of total energy, maximum available energy and maximum available study hours, which we can distribute to 2 activities, how much time I'll spend on academics and how much time I'll spend on EC. And I said that contribute to my benefit in the ratio of 3:5. And so that's more or less my statement. So what we did is that we identified a function z, which is a function of x1 and x2. If x1 is the time allotted for academics, x2 is the time allotted for EC. Now this problem is known, where I have formed an objective function of maximization is equal to 3x1 plus 5x2, subject to this constraint, set of constraints, which is like available hours and the available. Now the same problem we can now think of from a different angle. Is that Now we choose how we are going to utilize the resources so that my resources together are able to generate me an activities level which is at par my initial or the primal problem that however, I'll have to ensure that my resources are exploited as less as possible. I'll come again, understand the English part. We'll talk about it. We'll try to understand it mechanically. We'll try to kind of intuitively understanding it, what I am exactly doing, and also mechanically how to form the dual. So dual is a statement of my problem, which was originally also sometimes called primal. Dual is an approach to look into primal from a plane. You remembered when I was trying to solve my primal using graphically, my x-axis and y-axis are nothing but my activities axis, correct? What level of activities we are choosing. Now, if you imagine a space where my x and y-axis are essentially the shadow prices, means how much of the resource one can contribute to my benefit, how much of resource two can contribute and try to map those constraints on that space, then what I will get is a totally different view of the existing problem. Just remember those things, try to recall these things, try to digest these things. Okay, everything will not come pretty clear for those who are new, for those who already know or possibly been able to give the statement that this is the duality definition. So every primal problem, there is a dual problem. Second statement is that when the optimality is achieved, the solution of primal space and solution from the dual space will converge. I repeat, when the optimality is achieved, the solution from the primal space will converge with the solution from the dual space. However, in the primal, we have our decision variables was the level of activities. In the dual, our decision variables is the level of y1, basically the resource y or the first resource, on y2 is the second resource. In this example, first resource is number of hours available, second one is the number of calories available. Remember, the constraint means in the primal I have a set of constraints. My constraint was my total hours available is less than equal to 8. Now when I formulate the dual, my constraint, what does that mean? If I am using hours 1, then that kind of how much that kind of contributes. Let's just we'll stop it here because it will become more and more confusing. We'll do some mechanical things and then we'll see if we can come back to this concept. Before I go through these statements, this is exactly the basic understanding about formation of primal and the dual. So in the primal, if it will be minimization problem. Now what is the English for this? If you are trying to maximize profit by selecting the level of activities, in the dual you will try to minimize the resource utilization such that your profit is maximum. When you will achieve your maximum profit? When you have achieved your optimal solution. Okay, so in a nutshell, in your primal, if the problem is a maximization, in the dual world, your problem will be minimization. In the primal, whatever was the constraints, they will be the variables. Now, what was the constraint in the primal? Resources. So essentially, in the dual, resources will be your variables. Now, resources will be your variables means the contribution of resources, or y1 contribution of resources like y2. In the primal, if your resource constraint is less than equal to, in the dual, the constraint will be greater than equal to. Whatever are your variables in the primal now will be your constraints. What I'll come back to English statement is that in the optimum, what we have done, we have tried to identify the level of the activities which exploit certain set of resources, and resources which are constrained by the highest level that are available with me. So in the primal, I choose the activity levels such that together those activities give me certain benefit and I try to maximize the benefit. In the dual, I try to select the level of resources that I'm going to exploit or kind of contribution, so that those resources are able to generate the same level of activities which I have generated in the primal to achieve optimal solution. We will see this as when we go through some of the examples, how to formulate. Just remember these things. What I am saying is that when the optimality has achieved, we will do this. We will just do certain solution in Excel also. When the optimality achieved, the primal solution and the dual will converge. Okay, so you'll have to memorize these things in order to solve the problem. But memorization is not the fun. The fun part is to understand what I am doing and why I am doing. Now the second question is that what is possibly mechanical? Why should we use dual? You will encounter a lot of situations in real life as well as in the books when solving the primal is not very convenient. In those instances, when you solve the dual, my equational form a little bit simplified or convenient to solve. Let us see these things. Okay. Now,
Sir, I have one doubt, sir.
yes, please. You will
Yes,
have a
sir.
plenty of doubts, so I mean, I don't mind. Yeah, please.
Yes, sir. So, sir, the thing is that the primal works on the output, sir, and the dual is works on the input side. Is it correct?
Absolutely correct. You're bang on target. So that's precisely is the approach of solving a problem. You're bang on target and targets. In the primal, I am trying to increase my output when I'm constrained by input. In the dual, I am trying to minimize my input, ensuring that I achieve certain level of output. Okay, you're just theoretically, philosophically, you're just bang on target. So essentially, every problem has this both way of looking into the problem, and depending on your problem context, you may decide whether you would like to go to the primal approach. So essentially formulations are related. So if you formulate LP primal, you can formulate dual also. How to do that we will see. However, thanks for that input. You're bang on target. So anybody has got theoretical doubts on this, how to do, we will just see. Okay, thanks. Have done, possibly you have done 3 and 5 in the maximization. So what we are maximizing Z, you just can remove the lakh sign, so many zeros. You can say that 3x1 and 5x2 subject to x1 plus x2 less than equal to 8, and 100x1 plus 250x2 subject to some of them are less than 1250, and the non-negativity constant x1 x2 greater than equal to 0. Correct? The first line, this line is basically my y1 space. The second line is y2 in dual problem space. Okay. What are the resources? Resources are time and energy. Maximum availability 8 hours. Maximum availability resources are calories at 1250. Now, what are the worth of resources? Let us define two resources. Y1 is equal to unit worth of resources, time. Y2 is the unit worth of resource, energy. Now, if I say that I try to ensure that resources or the input is plus 1250 y2, that is my function. Now, can someone tell me that what should be my objective in terms of whether we would like to maximize this value or we would like to minimize this value?
Sir, minimize.
Perfect. Take an anecdotal evidence. Would you, when you are studying for academics or EC, would you really like outcome? Means would you like to be drain out as much as you can, or would you like to ensure that some of it is preserved for other activities? You would like to minimize. So resource exploitation should be always minimization. That's why in the dual world, if the primal is maximization, dual is minimization. So my objective is to minimize certain things, which is a function of y1 and y2. What are the coefficients of y1 and y2? Yes, that precisely is the right hand side equation values, which is the upper limit of the resource y1 and the other one, which is the upper limit of the resource y2. Which is 1250. Is my screen visible to everyone? Because
yes, sir.
Okay, thanks. Because I might be just pointing my mouse without knowing. Thank you. So these two, 8 and 1250, are now the coefficients of the dual function. Okay. Now, what I have to formulate is what are the constraints, right? Now, in the dual world, what is going to be the constraints? Just now, or rather we are discussing, is that in primal we are taking an approach which is output based. In the dual we are taking an approach which is input based. Now, just as a continuation of that statement, I said in the dual we would like to minimize input, ensuring that my output reaches a certain level. So what are the outputs here? Outputs here are x1 and x2. Okay. Now let us look into the output. y1 plus 100 y. So these three is basically which was the coefficient of my primal solution or primal equations. What 3 lakhs or whatever, I mean, if you are just writing 3, which is fine. So what 3 lakhs represent was that per unit change in x1, what was the value change in my profit? Per unit change in y2 x2, what was the value in x2? So if you just look into these things, now this is basically x1, this is basically x2. Okay. Whereas y1 and y2 should be greater than or equal to 0. That means either I will not at all use the resources or I will use the resources more than some positive value. So this is my dual of the earlier problem. So for those of you who has Excel in front of you, you can solve this problem. Can we just solve this problem? I mean, or rather, let us do one thing. Let us go back, come back to these things. Let us go back to right. Can you? I mean, I think you. I have already shared the Excel, right? All of you have the Excel. So, what was the optimal value of this equation or this LP? Anybody remembered? $30. I mean, if you're still looking for that, download the Excel. You can see it is already given 30. Okay.
Yes, sir.
Okay. Now, can you formulate the dual instead of looking into if it is already available with you from here? Means when I'm saying formulate, it's already formulated. I'm saying just put it in Excel and find out the optimal solution. dual and find out the optimal solution. And obviously, we'll see. Can you do it hand in hand so that you don't wait for the exams to at least even how to input? Because in your exam, you'll have to do that in Excel, provide the solution as well as thought process. Input the dual variables. Anybody would like to say what is the solution? What is the optimal value? Am I audible? Okay. So since no one is talking, either all are working on it or no one is working on it or some people are. So I will. Roll number. One 196. Disha Gupta. Vidya 182. You there?
Yes, sir, I'm there,
Yes, Aditya.
but I'm not able to convert the primal problem into this duality problem.
Okay. So follow this table. Oh, it is already written. Follow this table. Try to follow. This is pretty simple. You should be able to do it. Because once you can do the smallest thing, you can do any big problems. If you are stuck here, the bigger the problem, you'll be more afraid. Okay. 199. So can someone enlighten me? You have this some minimum attendance criteria. Is it there?
Yes, sir, 80%.
So how do you define attendance is taken?
I'm not sure Shravani ma'am actually does that.
Okay, so you do not have in any class hardcore or पुराना roll call type का कुछ नहीं होता है ना?
No, sir.
Okay. Okay. No, because the reason I'm asking you this is that I see that some people are absent. Maybe whatever reason, I'm not saying they are intentional and absentees, or maybe some of them are present always but don't want to talk. So that's what I was trying to understand. The reason for me calling out the names is that I haven't heard of some of these people. I mean, Aditya, obviously, possibly, I have heard about from him. For many of the names that I kind of called out. So I don't have problem in terms of that, but at least I will get to know then if, if there is someone who is genuinely interested, and it's better. Anyway, so is there anybody who would like to say that? Yeah. Yeah, sorry, go ahead. I possibly was saying something. You were cut in between. Okay, fine. Those who are able to formulate Excel, hello. I believe I'm audible still, right?
Can you show one example for us? It would be better.
Correct. Okay, fine. We'll do that. So please go ahead telling me which is a primal problem for ACADC. We'll stick to this example. It has nothing to do with ACADC. It's just a LP problem on which ACAD is just representation of x1 and x2. So can someone give me the values of x1, x2? Since I'm not opening and don't want to keep switching. 3, 5, right?
Yes, sir. 3 and 5.
Okay. Now I have a resource which is hour, and then there is another resource which is calorie. Give me the
Sir, x1 plus x2 less than equal to 8. And second one is 2x1 plus 5x2 less than equal to 25.
and then what we are doing is that basically what are the
Yes.
levels are basically coefficients. So it's like how much of ACAD contributes to my benefit and how much of EC contributes to my benefit. So in the activities, we said that we can select any random values to start with. It doesn't matter I select 0, 0 or all these things. In Excel, we can select anything. And then I get a total profit, which is equal to sum product of this coefficients. So what next? Without looking into the solution of the Excel that I have shared. Now what should I do? What is lacking here?
One more sum prod for R and calorie both.
What is that actually?
Uh,
Okay, fine. Mechanically you're correct. What is that actually? What is
formula.
this? Yeah, formula is fine. What is this?
Maximum limit R.
Correct, correct. So this is the maximum limit, but this is exactly here is what values
The
and
resources used.
correct, very good. So it's basically is the resources that are I'm using for this level that I have chosen. Okay. Sorry. Okay. The next one is like a replica of first one and second one. We have done this in these things because you are not responding. That's what you are going to do. So now what I'm going to do?
Solver.
What is it?
We have to optimize.
I'll go to solver. Okay. Just someone tell me what I have to do. Okay, this part is fine. This part is the set objective function is okay. This is maximization, minimization problem. Primal was
Maximization.
okay, fine. What I will do? Which change? Which cells am I changing?
Activity levels.
Thank you. Okay, so if there are 10 different activities, you will have to then select those 10 levels. Now, fine. Now, what are the constraints? Constraints I will add. What are the constraints?
Then the maximum value. So F6 should be less than or equal to H6. And similarly, F7, sorry. Oh, yeah, F7 should be less than or equal to H7.
Okay. So I'll not put that non-negativity constant for the time being. Also, I'll choose simplex. If I select GRC nonlinear, you might see some non-integer values into that. Okay. What I've got is my optimal solution as 30. Okay. Now I'll come to the sensitivity report just in couple of seconds. Okay, fine. What are these things? Shadow price. We just discussed this class. We're not doing anything new. If anybody who's just on the class and at least listening will be able to recall what is the shadow price? What is 1.667?
Every unit increase in 1 point, like that will be its
A
effect on the
contribution to my profit. Yeah. Yeah. Thanks. I mean, like that. So let us try to now what we are going to do is we will form the dual. Dual, we said every constant is basically a dual variable and every resource is a dual constraint. It is already written already there. Okay. Is equal to 8 y1 plus 25 y2. It means is how much of, sorry, into. It essentially shows me how much of this input I am exploiting subject to constraint, able to generate the activities up to certain values. The constraint is, first constraint is 1x1, which is this column, okay, 1x1 sorry 1y1 plus 1y2, which is this column. So now what is I'm basically, so if you just can concentrate is that this much of resource y1 I am consuming for this activity, this much of resources of y2 I am consuming for these activities. So they together is basically tells me how much of x1 I am now attaining, correct?
Will it
Sir,
be
should be
2y?
2y2.
Yeah, 2 by 2 into y2. Perfect. Now this is the level of x1. Now what should be the constraint here? Just recall what we have stated earlier. In the maximization problem, we were trying to manage certain set of output activities to give me maximum profit. In the dual space, I am trying to minimize my set of inputs to ensure that highest level of activities we are able to achieve. So this is basically tells me the level of x1. This has to be more than what is the contribution coefficient, which is 3. And similarly, this should be more than 5. So 1 into y1 plus y2. Okay, 5. So whatever was less than constant has become greater than constant. Okay. Whatever was maximization problem has now become a minimization problem. Okay, can you solve in your hand now this problem? Another LP is nothing. If you just forget about this, it's another LP. Can you solve your problem this LP? Do it in hands right now in the class. I can simply say the theories and leave you, but do it now. Let me know if you are facing any problem. Okay, if you are not trying, tell me now, what should I write here? This is for activities.
We are trying just 2 minutes.
Yeah, sure. I mean, I'm not rushing you because I'm not able to see anyone what exactly you're doing behind the screen. So please don't. I'm blaming that you're not trying. I'm sure at least 50-60% of you're trying.
So won't cell J3 be 25?
Which cell?
So J3,
In this
is 8y1 plus 25y2. So
just give me. Okay, you are saying. Yeah. Now ask your question.
so cell J3 should be 25 and M.
Oh, okay. Yeah, sorry. Yeah, you are correct. Correct. What is this going to be? Anyone? Okay.
So 30.
How much?
30.
30, right?
Yes.
Okay, so those who are watching me not been able to do it, can you tell me what should I do now? I would like to do what? This cell is 0, 0. Okay, if I change the level of my exploitation of the resources, or when getting how much I can get out of the resources. So what should I do it here now? I'll try to optimize this. Right? It is the same problem. Now I'm trying to optimize this. I'll solve it for what? I'll solve it for what? Maximization?
Minimization.
Correct. So I'll solve it for minimization by changing which cells? By changing these cells. Okay. Now then, subject to constraints, which is maximum how much I can get benefit out of per unit Eckert is 3, or I should get it. That's how my input should be. Maximum benefit should be greater than or equal to. Yeah. So this should be greater than or equal to this. Now the non-negativity constant I'm still not adding here. It's a minimization problem. I go for simplex LP. Solve it. I do a sensitivity analysis. Okay. So this is your primal problem, right? I mean, like where we have tried to using the maximum possible. Primal problem has a sensitivity like this. Bear with the formatting aspect. If you look into your dual problem, this is your dual problem statement. And what are the sense? Okay, now the questions to others. Fine. I'm pasting picture here with me so that this can be side by side. Okay, so question to others, do you see the similarities or kind of relationship between these two solutions? I think by side, just pardon me because I might be reducing a little bit. You can just put it in your own Excel. So can you see what are the similarities, the observation that you see? Okay. What is the value of y1, y2 when I achieved my optimality in my dual? Correct. So what is that 1.6 in my primal?
It's the shadow price.
Yes. So when I have achieved my optimality, whether I approached primal or whether I have approached dual, my per unit worth of resource value is same in my optimal solution, and therefore my optimal solution has converged. Okay. Now, if you look into the shadow price, okay, I will, before I go, what is going to be the shadow price in my dual? What are my constraints in dual problem statement? Those are basically the levels of activities, correct? In my dual problem statement, if I just go back to the Excel, if you look into this is what? This is basically the level of activities Eckert's, and this is the level of activities of EC. How much of the Eckert's is consuming y1, how much of Eckert is consuming of y2. such that I always achieve at least highest max like 3 and 5 in my equation. So can someone tell me what is going to be the shadow price for dual? Okay, what are the variables or constant variable in the dual? Guess here. I mean, I'm trying to push you a little harder from the tool-based things. At least if you are able to think it from this direction, you are able to slowly relate. Anyone can guess what is going to be the shadow price in the dual sensitivity analysis?
3 and 5.
Correct. What are those 3 and 5?
I think academic and non-academic.
No, that part fine. What is the 3 and 5 signifies actually? Why do you think 3 and 5? So 3 and 5 is the level of activities on optimal solution in your primal. Okay. So final value is 3 and 5. Okay. Now this problem is a little bit of symmetric problem. Therefore, इसमें क्या होता है कि you basically exploit all your resources. What does that mean? You have exploited your 8 hours of academic time, entire calorie. What does that mean? Does that mean is that you try to utilize all of your resources as much as you can possibly do. That's why for both these resources you have a shadow price, because those resources are now valuable. You don't have plenty of times, you don't have plenty of calories. You have already achieved, you have already in your optimal value. When you have achieved optimality, you have actually none of those resources are available in your hand. Okay, but in reality you might see there are 10 different resources. Some will not have a shadow price. It is at that point of time you need to understand whether you should approach the problem from the primal approach, or you should take a dual and do the primal approach, do the optimal. Because when the optimal is achieved, both primal and dual would same values. Okay. So let me just go through the statements that we were thinking to discuss. To relate some of those things. Okay.
और क्या हो तुम्हारे कोट के पॉकेट में लग जाना स्वेटर जो.
Okay. Thank you. So how the dual is constructed? A dual variable is assigned to each primal equation or each primal constant. A dual variable is assigned to each primal equation or each primal constant, and a dual constant is assigned to each. When I was doing in Excel, in the right hand side to each beside each constant, I just wrote y1, y2. You don't need to write it. That's kind of mental mapping that you will be having. So the right hand side, the dual variable is assigned to each primal constant, and the dual constant is assigned to each primal decision variable. So means in your primal decision variable on the column you will have the constant. The right hand side of the primal constant means the beginning LP constant, and that is precisely, she was pointing out that cell J3 should be 25. Okay, and thanks for that. So right hand side of the primal constant provide the coefficients of dual objective function. So what has happened? You have a limited resource. You want to ensure that resources gives you maximum benefit, but subject to that you achieve your maximum benefit. But at the same time, even though you are achieving your maximum benefit, you would like to ensure that resources are as least possible exploited to achieve the maximum benefit. Okay, we in the last top line, I mean, this is just to give a perspective. If someone is trying to match it, exact framework to framework will not match. Think it the kind of analogy is that you are on a kind of senior executive, or possibly on possibly the CEO of an organization. You are representing to your shareholders. In quarter one, you have met your shareholders when they have seen and they told you that we think this company is not best. Okay. Now that statement is pretty vague, isn't it? Not doing its best means a lot of things, but then you come back and you decided that okay, next quarter you want to tell them that or you want to show them some improvement. What are the possible ways you can show them the improvement? I mean, don't put soft aspects like better coordination, blah blah blah. I'm saying purely from sorry, financial point of view, how you can show improvement.
Increased revenue or increased profits.
Right. Are they related?
Yes, like we can increase profit either by increasing the revenue or decreasing our expenses. So they're related in that way.
Correct. So that's precisely the point. When you increase the revenue, what is going to happen? Your cost is going to be. Okay, now I'm asking more practical questions. So if you'd like to try to increase the revenue of any organization, how it is going to impact your cost aspects? Think practically as a business owner, just a shop owner also will think the same way.
Cost will increase a bit.
Correct. So in a transient period, your cost will increase because, and possibly in a long run also, because you can increase either through capacity expansion, either through branding, blah, blah, blah. Cost will also increase. However, when you like to decrease your cost, what exactly you're going to do broadly means at a very high level, you're going to possibly optimize your operations, you're possibly trying to see resource utilization, how it is happening. So all I'm trying to tell you is the same problem where shareholders would like to tell you that show me something more interesting, show me that you're exploiting. So you can do this way that I will increase the revenue. That might not increase the profitability, but still I'll see much more dollar values at the bottom of the financial table. Or you can say I will not increase the revenue because my entire resources are not. So I will do internal optimization to reduce my cost. So the revenue might be same, but because cost is reducing, the profitability will increase. So there are a lot of debates and all these things. This is available in the literature that should concentrate on profitability and revenue. We're not going into that in the OR class. Bottom line here is that when your company is operating at its optimization level, when your company is operating at its optimum level, so these two problems will take you to the same single numbers. So exactly that is the same thing. So every primal problem, whether you approach from input point of view or output point of view, any LP problem, if at all it has an optimum solution, when the optimum solution arrives, both the dual and the primal will reach eventually to that optimal solution. Okay. Now, how to mechanically do it? I mean, I just have shown you mechanically do it, remembering these things. Yeah, that is possibly easy, but that is not fun. There is not much of fun in that. Because the more, even if you sit with one problem, solve LP, then solve the LP equation, then go to the dual, solve it, and start thinking what is exactly happening inside the problem space, or what could possibly be happening inside the problem space. That's when you start getting the fun out of it. Okay. And that's when you become an expert in terms of analyzing the outcome or the output of your OR table. Anyway, a dual constant corresponding to a primal variable is constructed by transporting a dual constraint corresponding to a primal variable column into a row with the primal objective coefficients becoming the dual right hand side. We have just done it, so there is nothing new. I'm just writing it in English now so that you remember what exactly I'm doing. The remaining constant coefficients comprising the dual left hand side coefficients. That is precisely what we have done here. Okay. A dual constant constructed by transporting the primal variable column into a row with the primal objective coefficients becoming the dual right hand side, with the primal objective variable becoming the dual's right hand side. So in the next page, if you see, the right hand side is 3 and 5. Okay, and the remaining constant coefficients comprising of the dual left hand side coefficients. So this is basically 1 y1 into 2 y2 is values. 1 y1 into 5 y2 is greater than equal to 5. It basically says is that you exploit resource x1 and resources y1 and y2 such that they together give me a value which is greater than 3. Similarly, you exploit these two other resources such that they together give me a value which is greater than 5. That's precisely what it is trying to tell me. And when the optimum value is achieved, whether you have achieved from the primal route or you have achieved through dual route, it's basically same thing. Oh, you understand duality, what is there? I mean, एक ही तो problem है, हम ऐसे घुमा फिरा के क्यों कर रहे हैं? So essentially, we are doing a problem with 2 variables, 2 constants. Imagine a problem with 7 variables and 2 constants. Okay. Imagine a problem with maybe 10 variables and 3 constants, or whatever. I'm just giving an example. Where the constants and number of equalities you will eventually get are no way closely matched. So in that case, if you convert it into dual, it becomes something solvable. Okay. The second thing is that duality gives you a very interesting knowledge about your resource, how much it is worth of, your activities, how much each activities are worth of, and to what extent you can exploit your resources, to what extent you can achieve your different activity levels. So when solving primal and dual solutions kind of things together helps you to understand this kind of decisions. And sometimes primal problem is not easy to obtain. It's a common equation algebra here. I mean, if you have 10 variables and 3 equalities, will you be able to solve anything up for those 10 variables? Possibly no. Means at least not officially it's possible. So what you do then? I mean, this is a question to everyone. If I have 4 decision variables and 2 constraint, okay. If I have, I'll repeat, I have 4 decision variables and 2 constraints. This is not a market captured. If I have 4 decision variables and 2 constraints in my primal, in my dual, how many decision variables will be there? Any takers?
I think 2 decision variables.
And how many constraints?
4.
Good. Is it clear to everyone?
Yes, sir.
Yes.
Oh, okay. Thanks a lot. Clear and you are still silent means you'll either get it no from this person or later. So this is how I'll do that little bit of example, tell you if you just look into this, what I was saying, it's more or less same. The primal is a minimization problem, so dual will be maximization problem. The primal has 2 constants, one is greater than, one less than constant. So the dual will have exactly 2 constants, one greater than, one less than. So here whatever they have done is that they have considered y1, negative y1 as greater than equal to sign. Okay. So these are certain things, is just operationalization benefits, they will do it. I mean, if you solve some of the problems in your book, you will realize theoretically you will understand for operationalization you when you were young in class 11 12 we will often shift the x-axis or the origin so that it starts from 0 0. So those are the kind of things that happens in OR also. But essentially if it is a minimization problem, in dual it's a maximization problem, and dual you start with the input resources. Okay, this we have already covered. I'll stop here quickly. So once I form the dual, its dual is like nothing, another LP only. I mean, all the approaches, whatever you have learned about LP, like you can form the simplex W and solve what is the best. Okay, let's do one thing. How many decision variables my primal have?
3.
3.
3.
And 2 constants. Can someone tell me my dual equation and objective? Looking at this number.
Objective will be 210 y1 plus 200 y2.
Great. Maximization or
Minimization.
good. Anybody else would like to try the constraints? Give me one constraint, how it will look like.
5 y1 plus 10 y2 should be greater than equal to 50.
Good. Anyone else? Second constraint?
6y1 plus 8y2 should be greater than equal to 20.
Good. Okay. If any of those maximization equation has a negative sign, you just have to ensure that what sign you are taking or you are using in your constraints. Okay? Or even your primal constraint may be such a way that उसमें greater than equal to sign आ गया. Okay. So understand what is inside the problem, what is happening, then only you will understand how to put those signs, because simply memorizing might work, in many instances it may not work. Okay, great. So we will so if you can take a snapshot, I mean, I'm sure next class we will not devote directly for duality. I can and this problem and see whether primal and dual are in a way helping you to understand. A couple of questions which I'll share while sharing the PPTs. Okay. So this is basically the dual equation. Just now some of your friends have already mentioned. It will minimize 210 y1 and all these things. So now this initial primal, I have 3 variables. So that means if I need to plan or map, I need 3 axes x1, x2, xt. But if I want to map dual, now I will be working with 2 axes, which is y1 and y2, because right now my LP has only 2 variables, y1 and y2. Okay, so if we plot those constraints to this line, the first line is the first product constraint. Do you recall what is the dual product constraint? Is that 5y1 plus 10 y2 is greater than equal to 15, correct? So that's the line here, 5y1 plus y2 is greater than equal to 10. So the first constraint is about how much product 1 is exploiting all the resources so that my total benefit of product 1 out of all these resource utilizations is at least the coefficient value in my primal. Okay, I'll tell again. My resource y1 and y2 so that they together giving me at least as benefit of the coefficient of my primal. So my feasible solution range should be which area? Can anybody just try to answer this?
On the right side of line product 1.
Correct. Similarly for product 2, similarly for product 3. So remember, now I have an infinite feasible. This problem is about minimization. How will I achieve minimization? Graphically, I put the Z line far from origin and then slowly move it towards origin and see when I get the least value. And in this case, the least value is going to be either of this corner or this corner. Okay, so the next thing what we do graphically with it. So next thing what we do is that we kind of find out the values of W used primal notation. In dual we'll use W. You're free to use any notation because notation is immaterial. So we'll try to minimize W at these two values, whichever is minimum, that is my solution. If you can solve it, you will see that primal and dual are actually giving you both same solution. Okay. I'll stop it here for 3-4 minutes before I jump into other things. Any
Sir, I have one question. Like for both primer and dual solution, they will always converge, or there may be a cases that they won't be converging.
So if you have an optimal solution and one optimal solution, then they will converge.
Okay, sir.
Because those who are a little bit of imaginative, you have a feasible solution zone. When you approach the problem from the primal, you looked it from an angle of x1, x2 axis. What you are doing now, you are basically putting another 3 arbitrary axes, correct? These arbitrary axes are now y1, y2 or whatever, like your resources. So your problems or the problem is not changing. So whatever was feasible solution zone are actually remain same. You are just now shifting your origin from previously x1, x2 to now y1, y2, y3 or whatever. Means I'm saying. So problem remains same. So irrespective of whatever axis you chose, input based approach or output based approach, if at all you used to have an optimum, or if at all that problem has an optimum, it doesn't matter what. So your optimal solution is nothing but a point in an n-dimensional space. Now whatever you choose as your axis, the point will remain same. Now and at the value of the point, your objective will remain same. But you can say that now I'll choose x1 axis or I'll choose some other axis defined by y1, y2, y3. Okay. So that's a little bit difficult to visualize, but there are people who can visualize it a little bit more conveniently. But I think one way for one is the output based approach. That's one of your friend mentioned, and that's a very intuitive way of looking into these things. And if at all you have an optimum, whether you have taken input based approach or output based approach, you should ideally get the or converge to the same solution. And I just shown you in your optimum value, the dual's optimum y levels are actually shadow price of your primal, and that's the termed as dual price. Okay, and that's why shadow price is also called dual price. Similarly, your shadow price in your dual is going to be your primal main solution. Okay, so if there is no more questions, we'll jump to the other topic. If there is, you can ask this class, or you can say, sir, let us digest all these things. Just quick observation that I have, typically maybe it is for 1 or 2 people. In other section, I saw more queries coming. Some of them are really fundamental queries. The queries in this section are comparatively less. So either that could be that we all are in unison and all are understanding, or could be that whatever I'm able to understand समझ लेते ही समझने के लिए. So I would request raise in this class, if it is not possible by the time constant and all these things, that's a different story, because remember we spent nearly these 5-6 sessions on LP, and the reason is that this gives you foundation. If this is shaken or you are not able to visualize this foundation, you are going to impact in the subsequent classes also. And when the exercises, assignments, midterm and everything will come, they will start jumping like anything. So you will hardly have time at that point of time to clarify your doubts, which you might not be asking out now, thinking that अरे मैंने तो book पढ़ा ही नहीं, मैं तो कुछ पढ़ा ही नहीं. So if you have books, which is fine. If you don't have world, doesn't matter so far as learning matters. But yes, I mean books has some solved example, some quantitative things, and gives a kind of structure of studies. Is good. So please feel free. Okay, so if no queries here, so I believe that we will conclude here. We'll spend 5-10 minutes in the next class if you have very specific doubts about this. So we are in a way officially concluding the LP, which is called transportation and assignment problem. So what we have learned in LP is the sensitivity analysis, forming the duality, analyzing the solutions from the duality, understanding what could possibly the times when duality is a better option, and what is going to be their relationship between duality and primality, primal solution. So first of all, a couple of things. When you are studying, you remember some of these terminologies. So maybe you can just keep the core concepts and terminologies and then try to understand in that light. That will make your reading faster. Okay. Baki to for those who has background can do that. Well then, so next we will start with transportation and assignment problem. Okay. I'll just give a 30-second pause for you to, if there is very specific doubts or very specific queries or complaint or anything, any suggestion that you have, you might be having. No? Okay. Should I go faster? Okay. Silence, I'll assume yes.
But I feel the pace is very normal.
No, sir.
We can go by this.
Okay. So problem is there are certain things I'll have to see. I'll have to cover anyway. But let's see how we can do. But one request, at least try to solve some problem in LP formulation, solving in Excel, formulation of the dual, and doing the sensitivity analysis. So these 4 things, at least 1 or 2 problems. Actually, each problem you can work with all 4 of those things. So pick 2-3 problems, work any all 4 of these things, dig into the problem and start looking into it. The first they will say 10,000 different lines. Unme se sirf you will have to take only things which are important to you. Okay, I believe you are now expert in doing that. Okay, so transportation and assignment problem. What is the transportation and assignment problem? Forget about terminology that we are using. So now that okay. So now that we are comfortable with LP and kind of understood key what exactly in the and all those stuff. Transportation, remember transportation, assignment problem or any integer problem, all they are some special form of LP. Okay. So once you understand the fundamentals of LP, now what is going to go on top of that is constraints we are keep on adding. The kind of conditions we are kept on adding. So we have relaxed a lot of assumptions while we are formulating LP. Just give you one example. There could be a problem where your x1, x2, x3s are or can take only integer values. Okay, now that's a constant. How to handle that constant is that particular types of LP we will be working. Okay. Now, transportation and linear problem is also that special kind of linear programming problem in which goods are transported from a set of sources to a set of destinations, subject to the supply and demand of the sources and destinations respectively, such that the total cost of transportation is minimized. It is also sometimes called as Hitchcock problem. So, again, Hitchcock problem, but just remember, sometimes transportation problem are also known as Hitchcock problem. If someone is interested, can certainly look into the research paper why this name came. So basically it says that you have a set of sources, then you have a set of destinations. A typical example, during your exam, or rather before your exam, you have set of sources who possibly have solved all kinds of problems, are comfortable. Then you have a set of destinations who were dependent on those people. Before the exam, then all of a sudden things comes ki, how can I ensure those resources are exploited maximum so that the overall exam performance is improved. Okay, you might be thinking, or someone might be thinking behind the wall, how can this is transportation problem? Okay, let me come back to the real life problem. You have two manufacturing hubs which manufactures a product. For the timing, we'll assume that one kind of product. Both the manufacturing hub produces one kind of product, but they are not distribution centers. Then you have regional warehouses, are the warehouses from where all these products are distributed. So you have two production houses and three regional warehouses. So the regional warehouses has a demand, how much they can store. Your production house has a capacity limit, how much they can produce. So in its basic form, what we will assume, we will see, we will go through those things. It helps us. In the basic form, what will happen? Whatever is being produced, I am able to put it in my warehouse in total. I'll repeat, whatever I am able to produce in factory 1 and factory 2, I am able to store them in my warehouse 1, 2, 3. However, there are different capacity of warehouse 1, 2, 3. That means warehouse 1 may be entities, warehouse 2 maybe 500 entities, warehouse 3 maybe 300 entities. Now my decision problem is that I'll have to produce at this production house and send it to these warehouses. Now a critical thing is here, transportation of the raw or the final product from production center 1 to warehouse 1 is different than to warehouse 2 to warehouse 3. So there are costs associated with the transportation. That's a real life. So now the formulation of LP is done in such a way that products from this plant are sent to the three warehouses in such a way that your overall cost is minimum. Okay, so that's a basic form of transportation problem. We call it balance problem. Means जितना बन सकता है उतना ही रख सकता हूँ मैं टाइप का, ठीक है. और and destinations in aggregate are perfectly balanced. Okay. We will talk about in details in the subsequent classes. So just this is where the linear programming starts and how to solve it. There are 2-3 fundamental approaches of solving linear LPP of transportation type of problem. One important thing is that any problem which has this kind of nature can be formulated using this transportation problem. So the name came because it's means from where industry However, any problem which has a common nature related to transportation problem can be converted to a LPP and solved. Okay. So we will do this in detail in the subsequent classes. We'll spend 2 classes on transportation and assignment, and then we'll move to project management. So the way I would like to see is that I would like to, obviously given the time period and the space, we may not be able to cover everything within each of these individual components. My objective is to give you a hint of all these things, and then so that you can appreciate and read it in your time. Okay, so I'll stop it here without wasting much of your time. I'll be here online for 2 more minutes for those who would like to talk or have any doubts. For those who do not have doubts, you are free to log off. So there, you don't have to be formally be in the class unless you have something else.
Thank you so much, sir.
In practical cases, in case of unbalanced transportation problem, what do we do?
Yeah, we'll discuss about subsequent class. Think about it.
Okay, sir. Thank you.
Yeah.
The simplex table screen for a while. I had a doubt in that.
Which problem?
The initial simplex table problem where we did iterations.
This one, right? This one, right?
You're not sharing your screen.
Oh, I'm so sorry. Just.
Yes, sir. So here I did not get why we are writing S1 and S2 below basic. Like the variables are changed, so I did not get that thing.
Okay, so essentially when you start your Tableau, you are basically not, you don't have any slack or in the system. So it's basically now the objective is that I increase the level of X2, increase the level of X1 so that it becomes 0 finally, this 2, and all this slack is left from my system. Okay. So what I'm doing is that I am leveraging this resources first and using it as much as I can use, because my X2 is, because it's a maximization, I'm saying maximum benefit. It's a minimization means maximum impact. So now I will do is that X2 is giving maximum benefit. Among those resources which X2 is using, this one is the resource where X2 is impacting maximum because of this minimal ratio criteria. Okay. So means, okay. So that's why this is called pivot table. And once I have exploited the maximum I can produce or maximum I can do X2, this S2 as my freedom or degrees of freedom. That's why this is called, now I enter X2 and S2 is no more my basic variable. So these three are called basic variables. Okay, typically you will see basic variables are all those slack variables. When you start your Tableau, you will always have basic variables as all these slack variables, and these two are decision variables. Okay, so recall, if you are going through the books, you will see if you have n total variables and m constants, you have total n minus
N
m.
minus m.
So that much of basic variable. So this is because it's a symmetric problem, will not have any problem. What happens is that sometime what happens is that x1, x2 is dependent on a third constant. So you might like to have another row here depending on the equation. Okay. So that is written pretty clearly in the book. You will see how remember typically this is intuitively what we are doing is that we are crashing the resources in order to achieve maximum activities. Okay. Okay.
So in next iteration, the basic instead of S1 and S2, we are having it as X.
So S2 is no more my basic because it's kind of crash. Now I'll do, so basically what I am doing is that once I am done with X2, now I'll do with X1. But remember, whatever I am doing, the set of equations has to be satisfied at any given point of time, right?
Right.
Okay, so that's why, so this is not equal to sign. Do not consider that as an equal to sign. But here, if you see that I have 5, okay, X2 is equal to 5. And now is not equal to X2. This is the 5 solution for X2. This is 3. Here it is 25. If you remember that I have not even achieved my optimal. So if I put X2 as 5, I have still not achieved optimal. So next iteration you will see, you will get X1 which is 5, which is X2. Solution is 3. And at 5 and 3, your solution is 30. Columns of these two decision variables are 1, rest all are 0. So whatever we have done as of now graphically or whatever way, exactly same thing is done algebraically. It is that they are trying to put it in a structural format for computers to convert it in a solvable iterative mode. Okay.
Okay, sir.
Thank you. Okay, see you then on Wednesday. Bye. Bye, guys.
Thank you, sir.
Cheers. Bye.